Optical Time Domain Reflectometer. An optical test instrument used to detect light loss in a single fiber by injecting short laser pulses into the core and then measuring the subsequent backscatter level at all points along the fiber. Breaking down the name reveals that an OTDR conducts timed measurements of reflected light. The OTDR operates on a principle similar to radar. A pulsed laser signal is injected into the glass fiber, and the subsequent backscattered or reflected signal is timed and measured for both power and distance. Let's take a look inside the OTDR. The basic components are a transmitting laser, an optical coupler, and a receiving photodetector. The transmitter pulses light through the coupler into the core of the fiber. The detector receives and measures light returning through the coupler. If we look at individual pulses in slow motion, we can see that as the OTDR generates one pulse down the fiber core, multiple backscattered pulses are produced and travel in the opposite direction towards the detector. One main function of an OTDR is to accurately measure splice loss. It does so by measuring the backscatter levels right before and after the splice. Let's travel down a 100-kilometer fiber and see a sample of different optical events that the OTDR can detect. The first event is reflective and located right at the OTDR port. Because the OTDR is mechanically connected to the fiber under test, the connection creates an air gap, which causes a reflective dead zone where no measurement can take place. The OTDR will accurately measure the distance to a splice and the loss of power at that particular splice. All reflective events are detected and measured for reflectance, power, and distance. Finally, the far end connection is detected and measured. The OTDR is a versatile and valuable field instrument in the construction and maintenance of a fiber network.